Hello, this is Algebra 2, Chapter 7, Section 2. We're on page 1 of the notes, and we have this general box here about parent functions for exponential decay functions. They get all excited talking about exponential decay, and we could talk about, I don't know, radioactive isotopes becoming less bad over time or whatever, but the decay part comes because the base is between 0 and 1. That's the only thing that really matters here, is that base is between 0 and 1. If the base ends up being less than 0, it doesn't work at all. You alternate between positive numbers and negative numbers for for even and odd exponent variable. It's just a big mess. But between 0 and 1, if you look at the graph here, it's the same graph as before. It's actually just backwards looking, which is kind of funny, but it's the way it works. Couple key things. There were 2 points I highlighted last time that were key and important and always the same. The first one is the point 0, 1. That was true when it was an exponential growth function, and it's also true for exponential decay functions. In fact, it's just true for all exponential functions. And the second point that's always the same is this 1, b point. That is also true for every exponential function, whether it's a growth function or a decay function. Domain and range at the bottom. Oh, sorry, got ahead of myself. Asymptote, still on the x-axis. Still have an asymptote on the x-axis. A little dashed line action here, which they didn't draw because it doesn't do a lot of good to draw a dashed line on top of a solid line. But I will draw it there to say, hey, that graph is going to get really close to the x-axis. So the domain, now I'm ready for the domain. The domain is all real numbers. Might know that as R. Boom. Either way, the range is y is greater than 0. So the domain is all real numbers. The range is y is greater than 0. That was true last time as well. So the domain and range haven't changed. The magic ideas about specific points haven't changed. And in fact, the shape hasn't changed. It's just backwards. What do you know? Good times. So if we move on to example 1 here, we have -2 times 3/4 to the x. Now, I want to highlight that this 3/4 business is that number b, which is between 0 and 1. And I just want to make sure that it's clear that that's what they're talking about for that b business. 3/4 is smaller than 1, but it's positive, so that's what's going on. I'm going to erase that because it might get in the way of us seeing what's going on here. All right, plot 0, now for general exponential function, it would be 0, 1, but in this point, or excuse me, in this case, we do 3/4 to the 0, which is 1, but then it's multiplied by -2. So it's 0, -2, and 1, let's see, 3/4 to the 1 is 3/4 times -2, -6/4, or perhaps -3/2. So we have the point 0, -2. Sorry for pausing there. 0, -2. And we have the point 1, -3/2. And so 1, -3/2, which is like that. And we follow the same general shape. We go over to the asymptote. Boom. Boom. You know, if you were feeling spunky about this, you could certainly go ahead and plug in other points along the way. But it begins just below the x-axis passes through the 2 points and moves down to the left. And then the other thing to keep in mind here is that there's a negative 2 in front, so our exponential graph was multiplied by negative 2, and so that is what flipped it upside down. That might help you see that negative number multiplied in front is what turned the graph upside down. When you're drawing these graphs, you don't really need to draw the asymptote, but it's a good idea to know where it is to help you. So multiplying by negative 2 doesn't actually shift the asymptote at all. So the asymptote is still right there on the x-axis. That's the end of page 1. Thank you for watching.